Okay guys, we are doing triangle congruences today. The objective is that by the end of the period, students will be able to prove two triangles are congruent without having to show all the corresponding parts are congruent. Students will identify missing information needed to complete a proof/argument, and then you will be able to prove triangles congruent by side, 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 angle, side, angle, side, angle, side, HL, which comes later, and then angle, angle, side. There is no donkey, which is angle, side, side. Yes, I wrote that word. There is no such thing as that, okay? All right. So, think back to yesterday's lesson, or rather Thursday, Friday's lesson last week. Corresponding parts are congruent. So that means we had to get all of the sides congruent and all of the angles. So today we don't need to get all of the sides congruent or all of the angles congruent in order for the triangles to be congruent. So first of all, a couple of vocab words. If you have room on your note page or somewhere on your notes, write this down. So included means that they are in the same triangle and is between both angles or sides. Non-included is in the same triangle but is not between the two angles or the sides. So for example, angle A is included between BA, which is here, and AC. It is not included for BC, okay? And then angle B, or line BC, is included between angle B and angle C. Okay? So it has to be basically between. What angle is included between ED and EF? So here's ED and EF. It would be angle E or angle DEF or angle FED, however you want to write that. Which sides include angle G? So here's angle G. We'd have this side and this side. So line segment GD and line segment GF. Which sides include angle GDF? So GDF, whoops, we need that. GDF is here, so it's right here. Which sides include that angle? We would have line segment GD and DF. What is a non-included side for angle E? So angle E is over here. Non-included means it does not make up that angle, and it doesn't touch it. So you could say DF would be a non-included side because it does not touch that. You could also say DG or you could say GF. All of those would work. What are two non-included angles for ED? So here's ED and here's DF. Non-included angles. Angle E would be not included, this one, or EFD. So it's not between these two sides here, it's on the end. So like the included angle for these two sides would be right here. It would be between those two angles. Okay, so the first postulate that we'll learn today is the side, side, side postulate, which means that if three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. So triangle ABC is congruent to triangle DEF. Here's an example for you, which is a little bit different. So notice how we have this side right here, correct? It's within that triangle. Yes, it doesn't say that that it's congruent, but because it is the same line, QY is the same line as QY. So we are going to mark that congruent. Whoops. And by the reflexive property, okay, we get side, side, side. And the same side is congruent to itself. So QY, or YQ rather, is congruent to YQ. So whenever you have a side in common, it doesn't matter what kind of triangle you have. You could have a really like obtuse triangle like this, but if you have this line or segment down the middle, it's the same side for both triangles. State if the two triangles are congruent. If they are, state how you know. So number 1 has all 3 sides are congruent in both triangles. So that would be congruent by side, side, side. Number 2, you only have 2 of the 3 sides congruent. You cannot assume that that last side is congruent, so it's no. And I abbreviated, or I put down NEI, which means not enough information, and you can write that. Number 3, you have 3 congruent sides in both triangles, so that would be yes, so by side, side, side. And then number 4, so again, we have this line in the middle here that's in common, so this would be congruent to itself by the reflexive property. So yes, that is congruent by side, side, side. Or those are congruent by side, side, side. Postulate 4-2 is the side angle side postulate. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So AB is congruent to DE, angle A is congruent to D, and AC is congruent to DF. That means the 2 triangles are congruent. The most important thing about this is that the angle has to be between the 2 sides. Please, please, please write this down. The angle has to be between the 2 sides. If it is not, this is not a side angle, it's not a side angle side example. Here is one example for you that's a little different. So you have 2 sides that are congruent, and there's something not marked in the picture, right? But we know that vertical angles are congruent. So we could say that ACB is congruent to DCE because of the vertical angle theorem. And that would give us its side angle side. State if the 2 triangles are congruent. If they are, state how you know. So the first one, we have side angle side, side angle side. So that one would be congruent because it follows the side angle side. The next one, our middle line between those 2 triangles is congruent to each other because of the reflexive property. So again, that's side angle side. The angle is between the 2 sides. The third one, that middle line, again, is the reflexive property, but when you think about this one, okay, we have, on this one, we have side angle side, but the other one, did I do something wrong here? Oh wait, yes, this one is side angle side. My bad. Yes, side angle side. Oh, I guess all of these are yes then. Okay, then the next one, you have vertical angles between these 2. If they're across from each other, then they are always going to be congruent. They share a vertex, they share, the same rays to make up the angles. So that would also be side angle side. You guys try these 2. Give me the theorem that says that they are congruent. So number 1, you have your middle line as that reflexive property. It's saying it's congruent to each other. So those 2 triangles are congruent because of side, side, side. And then number 2, you have side angle side in both triangles. So those 2 are congruent as well based off of the side angle side theorem. Moving on to the back. So I would like you guys to try this on your own. So if you could pause the video and then go ahead and try those questions. And if you get stuck, you can play it and get the answers from me. So for number 1, angle C and angle F are right angles. Okay, we can say that angle C is congruent to angle F because all right angles are the same. They all equal 90, and that's called the right angle congruence theorem. If you guys don't have your reference sheet out from chapter 2, the handy dandy reference sheet, I would suggest you get it out. You don't need it, but it is a good idea to have. For number 2, so angle APB is congruent to EPK. So APB is here, EPK is here. Those two angles are vertical angles, so they are congruent by the vertical angle theorem. For number 3, AD bisects angle BAC. So BAD is congruent to DAC because of the definition of angle bisector. That is from chapter 1, a long time ago, but I told you it was still going to repeat itself throughout this year. Number 4, so they give us that angle B and angle A is 25. We could say that the measure of angle B is equal to the measure of angle A. I'm just plugging it in by substitution. And then the angle B is congruent to angle A by definition of congruence. Number 5, so on your paper you could turn it, but these two lines here are parallel, okay? So if we're looking at the transversal, and I just covered up all of those numbers there, if we're looking at that transversal, what kind of angles are those? 1 and 2 are alternate interior angles, and when we have parallel lines, that means alternate interior angles are congruent. For number 6, same kind of concept. Do you have, so this is your parallel line that you're dealing with, X, W, and Y, Z, and then this is your transversal. So 1 and 2, one is inside, one is outside. They're on the same side, so those are corresponding angles. So if we have corresponding angles, it means that their measures are congruent. Number 7, so in the middle, PR is congruent to PR because of the reflexive property. As long it's the same exact thing. So they have to be congruent if it's the same exact thing. W is the midpoint of QS. So if something is the midpoint, right, you guys should remember this, it means that those two segments are congruent to each other, and that is by the definition of a midpoint. Number 9, so given JK is 15 and PQ is 15. So again, this is kind of like the other one. We can plug, not that, we can plug PQ in for 15 by substitution to get JK equals PQ. Then we can say they're congruent to each other by definition of congruence. These theorems and postulates are always going to come back up, guys. You're going to continue to use these through this whole entire year of geometry, so make sure that you have those sheets handy. So for number 10, CD bisects AB, which means AD is congruent to BD because of the definition of bisects. Whenever you see that word bisects, it means something is going to be congruent to another thing. Okay, so on to 4.3. We are, this is some more triangle congruence. Here. So postulate 4-3 is angle side angle postulate, and that is if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So it has to be the included side. So the side, the side must be between the two angles. It has to be between the two angles. Okay, so then looking at our example here, we have two parallel lines here, right? So that means these 4 and 2, this is our transversal. 4 and 2 are congruent because they are alternate interior angles. And then angle 3 and angle 4 are also congruent because they are alternate interior angles. Okay, so then we also have that HI is congruent to HI because that line is exactly the same. So that being said, we have angle, so this angle, side, angle. Mark additional info if it's not shown in the picture. That's very important. Okay, so write a congruent statement for the two triangles that could be proven congruent by ASA, angle, side, angle. So, angle, side, angle. I'm looking at all of these as a whole. So, for this one, I have angle, side, angle. This is angle, side, angle. This one is an angle over here, and then I have the side and the other angle all the way over here. So, technically, this would be like angle, angle, side. So, that being said, triangle UVS is congruent to EON by ASA. You guys go ahead and try the next one. So again, it has to be angle, side, angle. The side needs to be in between the two angles. So we have angle, side, angle. We have angle, angle, side, angle, side, angle. So this one would not work, but GHO is congruent to CAT. And make sure that you have your corresponding vertices together. Okay, then theorem 4-2 is the angle, angle, side theorem. So if two angles and a non-included side, so that means it's not between the two angles, are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So non-included means it does not have to be between the two angles. So not between the two angles. So you have A is congruent to D, B is congruent to E, and then AC is congruent to DF. So that means the two triangles are congruent to each other. That being said, down below, so first of all right angles are congruent. So although these don't like have a line through them to say they are congruent, right angles are always going to be congruent no matter what. 90 degrees is always 90 degrees. Then, so we have an angle, we have an angle, we have an angle, 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 angle. So now we need a side. So the side would be this one here. And that is the reflexive property because AC is congruent to AC. So we can say these two triangles are congruent by angle, angle, side. So then we're going to go through here. Are the following pairs of triangles congruent? If so, state the theorem or postulate you would use to prove them congruent. So for number one, we have angle, side, angle, angle, side, angle. So yes, those two would be congruent by angle, side, angle. Number two, again, these are 90-degree angles, right? If this is 90 degrees, the other side is also 90 degrees because they are vertical angles. And vertical angles are congruent, 90-degree angles are congruent because 90 degrees always equals 90 degrees. So again, we have angle, side, angle, angle, side, angle. So this would be congruent by angle, side, angle as well. Number three, so we have two angles, but we don't have a side, but we could assume that that middle line is congruent because of the reflexive property. So this would make it angle, angle, side, and those two triangles would be congruent. For number four, again, you don't have enough information, so you need to try and make some information for yourself. I know that I have vertical angles here, right? They're across from each other, they share a ray, they have the same vertex. So those two angles are congruent, and then that being said, we have angle, angle, side, which makes both of those triangles congruent. flip to the back, and I want you guys to try that yourselves, okay? So give yourself like 10 minutes or so, and then come back and check your answers with me. I'm going to go ahead and go over them, but please try them on your own first. Okay, so angle, or number one, those triangles are not congruent because you have side angle or angle side side. Remember, we don't do donkey, we don't do that cuss word. That is not a theorem that would say those two triangles are congruent. For number two, all of the sides are congruent. So now we're pulling it back to 3.2 as well. All of those sides are congruent. If all of the sides are congruent, those two triangles are congruent by side, 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 or SSS. Number three, yeah, we could say that this is the same line here, but this would be either angle side, side. This side would be angle side, side. Ha, I just wrote a cuss word, big deal. And then the other side would be side, angle, side. So because they don't have the same form on either triangle, that would not be congruent. Number four, you have angle, side, angle, because that middle line is congruent by the reflexive property, so it's ASA. Number five, your vertical angles are congruent. That angle is in the middle, it's included, so it's side, angle, side. And number six, that would be angle, angle, side, because your side is not included between those two angles, so it's angle, angle, side, angle, angle, side. Then 7 through 12, so 7 is angle, side, angle. The side is included in both those angles. Number 8 is angle, side, angle as well. The side is between those two angles. Number 9, because we have that reflexive property, it ends up being side, side, side. Number 10 is not, because if you look at it, this side is side, angle, side, and then the other side is side, side, angle, or angle, side, side, whichever way you want to write it. And this one is not the same as this one, so they cannot be congruent. They have to follow the same pattern. Number 11, that line in the middle is reflexive, so we have side, angle, side. And then number 12 would be angle, side, angle as well, because we have vertical angles that are congruent, then we have our side, then we have our angle. Okay, moving on to the next one. So I already drew this picture down here. I would suggest that you draw it on your paper as well, just to help you out. And then obviously I did shapes to help me code out the two. So number one, you're given is angle A is congruent to angle X, and angle B is congruent to angle Y. So A and X, B and Y, so that means it's here. So for it to be angle, angle, side, we would have to have this side over here because you're having angle, 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 side. So BC is congruent to YZ. Angle A is congruent to angle X. AB is congruent to XY. So we have this, then this, and we want angle, side, angle. So that means angle B is congruent to angle Y. Then for number 3, we have angle C is congruent to angle Z. So we have this guy here and this guy here. Then BC here is congruent to YZ, but they want angle, angle, side. So if we're using this angle over here first, we need to use this angle over here as well, which would be angle A is congruent to angle X. Then our last ones here. So is it possible to prove the triangles are congruent? Number 4, those are reflexive, but it would be angle, side, side, or side, side, angle, so we cannot say that because that does not exist. Number 5, Number 5 is these two would be congruent. So those are vertical angles, and then we have angle, angle, side, because the side is not included. And then number 6 is a little different, but we know that these two are 90 degrees here. So that being said, we have side, angle, angle, or angle, angle, side, which is a theorem. So those two are congruent as well. If you guys have any questions, let me know. There will be a homework on Canvas for you to do. You need to complete that as well.